Hello everyone. Have you ever wondered how to build a robust type safe AI agent without getting lost in the maze of a complex code? Well, today we are diving into PydanticAI, a game-changing framework that revolutionizing how we build AI agent. I'm excited to show you why it become the go-to choice for developers worldwide. Let's get started. Before we start, let's understand what makes PydanticAI special. At its core is a Python framework that combines the power of Pydantic data validation with modern AI capabilities. Unlike traditional frameworks that often leaves you with undefined behavior and type inconsistencies, PydanticAI brings structure and reliability to AI development. What sets it apart is the built-in safety and validation, declarative agent definition, the seamless integration with modern AI models, and the built-in testing and evaluation capabilities. Think of it as your Swiss Army knife for AI development. It's powerful, reliable, and surprisingly easy to use. The philosophy behind PydanticAI is beautifully simple. AI agents should be as reliable as traditional software, and it embraces three core concepts. Type safety first, which means that every interaction, every message, and every result should be predictable and validated. The second concept is declarative over imperative, which means that we should define what our agent should do, not how it should do it. And the third concept is testing as a first-class citizen, which means that every AI agent should be testable as any other software component. This philosophy is not just theoretical. It translates into real benefits like faster development, fewer bugs, and more maintainable code. Now let's break down the building block of PydanticAI. At the heart of our PydanticAI system lies the agent component, which serves as the intelligent core of the entire framework. Agents are defined using Pydantic models, providing a structured foundation for their operation. These agents act as the primary decision makers, handling complex logic and processing tasks while maintaining a clear and organized approach to problem solving. Supporting these agents are the dependencies, which form a sophisticated resource management system. This component expertly handles all external services and resources, implementing automatic injection into agents whenever needed. What makes this system particularly powerful is its clean separation of concern, ensuring that each part of the system remains modular and maintainable. The results component brings reliability and safety to our system through its comprehensive type checking and validation mechanism. Every returned value is strongly typed, ensuring data consistency throughout the application. The system includes robust error handling built directly into its core while maintaining carefully validated outputs that meet predetermined specifications. For managing interaction and historical data, the messages and chat history component provide a sophisticated conversation management system. It implements type-safe message handling to prevent communication error, while incorporating built-in memory management that efficiently stores and retrieves conversation histories. This ensures smooth, consistent interaction while maintaining data integrity. The testing and evaluation component provides comprehensive quality assurance through its integrated testing framework. It combines automated evaluation tools with detailed performance metrics, allowing developers to thoroughly assess and validate their AI systems. This framework ensures that every aspect of the system performs as expected under various conditions. Finally, the debugging and monitoring component offers real-time oversight of the entire system. It provides continuous agent monitoring capabilities through well-placed debug hooks while actively tracking performance metrics. This enables developers to identify and address issues promptly, ensuring optimal system operation and maintenance. Today, we are building something truly exciting, an intelligent AI agent for technical support using PydanticAI. What makes this tutorial special is that we are not just building a simple chatbot. We are building a sophisticated system that can analyze problems, make decisions, and provide structured solutions. Let's dive in. Alright, before we dive in, let's make sure we have everything set up. You will need Python 3.8 or higher, the PydanticAI package, access to OpenAI's API, and the Nest Asensio package for handling async operation in Jupyter Notebook. This command will install the PydanticAI, and from here we are loading the environment variable, such as OpenAI API key. Alright? Now let's start building our AI tech support agent. We will start by importing libraries. Nest Asensio allows us to run async code in environments like Jupyter. Typing provides type hints for better code safety. Pydantic gives us data validation. PydanticAI provides our AI agent framework. Datetime helps us track when support request comes in. Let's run the code cell. Now let's build our data models. This is crucial because it defines how information flows through our system. First, we have the support query data model. Let's analyze each field. Issue stores the problem description. Severity indicates urgency level. A product identifies which product needs support. User ID tracks who submitted the request. Timestamp automatically records when the issue was reported. The base model inheritance gives us automatic validation. For example, if someone tries to pass an integer as an issue description, Pydantic will raise a validation error. After that, we have the support response data model. Let's analyze also each field in this model. Solution is the main answer to the problem. Next steps, breaking down the solution into clear actions. Escalate, it's a Boolean flag for cases needing a human intervention. Priority level, numerical ranking from 1 to 4 of urgency. Estimated time, expected resolution time frame. Next, we have the knowledge base, which is our agent memory. It is where we store known issues and their solution. This structure allows us to organize solution by product, map issues to their solutions, and store step-by-step resolution paths. Now here's how we populate our knowledge base. Let's run the code cell. Now let's dive into the architecture of our tech support agent. This code block represents the core configuration of our intelligent support system, and every parameter here plays a crucial role in its functionality. Starting with the agent constructor, we are using OpenAI GPT-4 as our base model. This string format is significant because it tells PydanticAI two important things. First, we are using OpenAI's API as our provider, and second, we specifically want the GPT-4 model for its advanced reasoning capability. The depth_type parameter set to knowledge base establish our dependency injection system. Think of this as giving our agent access to a specialized technical library. When we set depth_type to knowledge base, we are creating a contract that says this agent must always have access to our structured knowledge base. This ensures our agent never operates without proper referential material. For result_type, we specify support response. This is crucial for type safety and response consistency. Every single response from our agent must conform to the support response model we defined earlier. It's like having a quality control system that ensures every support ticket resolutions follows the same professional format. Now let's examine the system prompt. This is essentially our agent training manual. The prompt is structured in 5 key responsibilities. First, analyze customer issues using the provided tools. This instructs the agent to always use its analytical capabilities in conjunction with our custom tools. It's like telling a support technician to always use their diagnostic tools before making assumptions. Second, search the knowledge base for known solution. This ensures we are leveraging existing solutions before trying to create new ones. It is similar to checking a technical manual before attempting repairs. Third, provide clear, actionable solutions. This focuses on practical step-by-step guidance rather than theoretical explanations. The agent must give instructions that user can actually follow. And fourth, we have determine if escalation is needed. This implements our triage system. The agent must know when a problem exceeds its capabilities and require human intervention. Fifth, estimate resolution time. This helps manage user expectations by providing realistic timeframes for problem resolution. The final instruction, always use the available tool to verify information before responding, is our quality assurance measure. It prevents the agent from making assumptions and ensures all responses are grounded in our verified knowledge base. This configuration creates a robust professional support agent that combines the power of GPT-4 with structured technical knowledge and clear operational guidelines. The type safety provided by PydanticAI ensures our agent remains reliable and consistent, even when handling complex technical issues. What makes this implementation particularly powerful is how it merges advanced AI capabilities with traditional software engineering best practice, type safety, dependency injection, and structured response handling. This isn't just a chatbot, it's a professional-grade support system designed for reliability and scalability. Let's run the code cell now. Now let's examine two crucial tools that gives our AI agent its technical support capabilities: the knowledge base search and severity checker. These tools are essential for making informed decisions and prioritizing support case effectively. First, let's analyze our knowledge base search implementation. The decorator at Tech Support Agent tool is significant here. It registers this function as a tool that our agent can use, making it available during the decision-making process. The async keyword indicates this is an asynchronous function, allowing our agent to handle multiple queries efficiently without blocking. The function signature is carefully crafted for type safety. We are using run context knowledge base to ensure our tool has access to the correct knowledge base context. The square bracket notation here is crucial. It's telling PydanticAI exactly what type of dependency this tool needs to function. Inside the function, we first extract our knowledge base from the context. This gives us access to our structured knowledge repository. Think of this as pulling out the right technical manual for the job. We then implement a critical safety check. This prevents our agent from making assumptions about the products it doesn't know about, a crucial feature for maintaining support quality. The matching logic is particularly interesting. We are using case-insensitive substring matching here, which allows our tool to find relevant solutions even when issues are not described in exactly the same way. It's like having a technician who can recognize similar problems even when they are described differently. Now let's examine our severity checker. This tool implements a sophisticated priority assessment system. We start by defining clear severity levels. Low is 1, medium 2, high 3, and critical 4. This creates a standardized scale for issue prioritization, ensuring consistent handling of support cases. The severity assessment logic is particularly clever. We use .get with a default value of 1, ensuring our system gracefully handles unexpected severity level by defaulting to low priority. Then we have our automatic priority evaluation system. This is a crucial safety feature, regardless of the reported severity. If our system detected critical keywords, it automatically elevates the priority. It's like having an experienced support manager who knows when to escalate issues based on specific trigger words. Finally, our return structure provides a comprehensive assessment. We are not just returning a priority level. we are providing a complete evaluation package that includes escalation recommendation and estimated resolution times. The time estimation uses a simple but effective formula where higher priority issues are allocated more time, reflecting the typically greater complexity of critical issues. Together, these tools create a robust system that can intelligently assess, prioritize, and match issues with solutions, all while maintaining type safety and professional support standards. Let's run the code cell now. Now, let's examine our main support query handler. This is where all our components come together to create a complete support system. This async function serves as the orchestrator of our AI support operations. Looking at the function signature, we are using async await pattern here because support operations can take time and we want our system to remain responsive. The function takes a support query type as input and promises to return a support response. This type safety is crucial for maintaining reliable support operations. First, let's look at how we initialize our knowledge base. This knowledge base structure is particularly interesting. We have organized it into two distinct sections: known issues and solutions. Think of known issues as our quick reference guide. It maps specific problem descriptions to their immediate solutions. The solutions section, on the other hand, is more like our detailed troubleshooting manual, providing step-by-step resolution paths for different categories of problems. What makes this structure powerful is its flexibility. The known issues dictionary handles exact matches, while the solution dictionary provides more general procedural guidance. It's like having both an FAQ section and a detailed technical manual available to our agent. Now let's examine how we process queries. This is where the magic happens. We are formatting the query in a structured way that helps our agent understand the context clearly. Notice how we are using string formatting to inject our query parameter into a template. This standardized format ensures our agent receives consistent, well-structured information every time. The DEPS, or the dependency equal KB parameter, is crucial here. We are passing our knowledge base as a dependency, giving our agent access to all the technical information it needs to make informed decisions. This dependency injection pattern ensures our agent always has access to up-to-date support information. Finally, the return statement. This looks simple, but it's doing important work. The .data ensures we are getting a properly formatted support response object. Remember, this is typed, so we are guaranteed to get back a response that matches our defined structure. What makes this implementation particularly robust is how it combines structured data, which is our knowledge base, with type safety through Pydantic models and AI capabilities via our agent, into a cohesive system. It's not just passing messages back and forth, it's creating a true intelligent support system that can understand the problems, look up solutions, and provide structured, reliable responses. The asynchronous nature of this handler also means it can scale while multiple support queries can be processed simultaneously without blocking each other. This is crucial for a production environment where you might be handling numerous support requests concurrently. Let's run the code cell now. And now for the final part. Let's examine our main execution block. This is where we put our AI support system to the test in real-world scenario. This section demonstrates how all our components work together to handle an actual support case. Let's start with the conditional statement. If underscore name equal main, this Python is crucial. It ensures this code only runs when we execute this file directly, not when it is imported as a module. Think of it as our testing ground where we can safely experiment with our support system. We first import a Sensio module. This import is essential because we are working with asynchronous functions. Sensio provides a runtime environment that allows our async code to execute efficiently. It's like setting up the stage before our performance begins. Now let's look at how we create a test support query. This is where we simulate a real support ticket. Notice how we are structured this test case. We have chosen a common but serious problem that will really put our system to the test. The high severity and the mention of server restart should trigger severity of our priority assessment rule. The execution of our support system happens here, in response equal asyncio.run. This line is doing more than it might appear. The asyncio.run function creates an event loop, execute our async handle support query function, and manages all the asynchronous operations. It's like a conductor orchestrating all the pieces of our support system to work together harmoniously. Finally, we have our output section. This structured output demonstrates the comprehensive nature of our support response. We are not just getting a simple answer. We are receiving a complete support package that includes the main solution to address the immediate problem, clear actionable next step for implementation, an escalation flag if a human intervention is needed, a priority level to indicate urgency, an estimated time for resolution. Let's run the code cell now. And we get the response. Let's examine the response we receive from our AI support agent and break down how it demonstrates the intelligence and effectiveness of our system. Starting with the solution provided, we can see that our agent has constructed a comprehensive, well-structured response. The solution begins with an immediate assessment. This seems to be a critical problem. This shows our agent recognizes the severity of database connectivity issues following a server restart. The agent then follows a logical troubleshooting path, moving from the most probable cause outward. Notice how it creates a systematic approach. First, it's checking server logs, then network connection, and finally database-specific issues. This matches how an experienced database administrator would approach the problem. The next step section reveals our agent's ability to break down complex problems into actionable items. Let's analyze these steps. Check server logs. This is prioritized first because it provides immediate insight into what happened during restart. Check network connection, which is a logical second step if logs shows successful initialization. Verify firewall settings. Essentially, after server restarts, a security setting might reset. Verify database connection setting, checking configuration after ruling out infrastructure issues. Confirm status of database services, a final verification that all components are running as expected. The escalation flag is set to true, which demonstrates our severity checking system working as intended. This makes sense given that database connectivity issues can affect entire systems and business operation. The agent recognized this was not a simple configuration issue that could be resolved through basic troubleshooting. Look at the priority level of 3. We can see our priority assessment logic at work. The combination of high severity in the input and the mention of database connectivity triggered our priority rules. This priority level aligns with enterprise support standard where system-wide issues require elevated attention. The estimated resolution time of 6 hours is particularly interesting. This comes from our formula where priority level is multiplied by 2 hours. This estimation reflects the complexity of database connectivity issue, accounting for time needed. What's particularly impressive about this output is how it balances technical accuracy with practical usability. The solution is technical enough to be effective but clear enough for implementation by IT staff of varying experience levels. It provides a structured approach while remaining flexible enough to adapt based on findings at each step. This response exemplifies how our AI support agent combines knowledge-based information with intelligent problem analysis to create solutions that mirror human expert thinking better. The systematic approach, appropriate escalation, and realistic time estimation all indicates that our agent is functioning at a level that could assist in enterprise support scenarios. And there you have it. We have covered the basic of PydanticAI and we built an AI agent from scratch. This is just the tip of the iceberg. There's so much more to explore, from advanced pattern to real-world deployment. If you're interested in diving deeper into topics like multi-agent system, advanced agent pattern, production deployment, and performance optimization, let me know in the comments down below. Don't forget to like and subscribe to my channel for more AI development content. Thanks for watching and happy coding.